Yes, guys, we have another question of emerald. Block A and B are identical, having 1 kg mass each. A is tied to a spring, so this is attached, and of force constant K, and B is placed in front of A, placed in front, touching it. Okay, so placed, so this it is not attached. Block B is pushed to left so as to compress the spring by 0.1 meter from its natural length. Okay, it has been pushed to a certain extent. Let us just call it as using a lot of x's in this question, so I'll just call it as y is equal to 0.1 meter. The system is released from this position, and coefficient of friction for both the blocks with horizontal surface is 0.2. So both of them have a friction of 0.2. So what we do is, as soon as we get that, we calculate the F max. F max for both would be equal of body A as well as F max of body B. That would be, because they are both 1 kg body, so 1 kg into 10 is the G into 0.2, so that is a 2 Newton each. Take K is equal to, so now K is given in one of the parts, we wonder why. Kinetic energy of the system comprising of the two blocks will be maximum after traveling through a distance x naught. Yeah, so the kinetic energy will be maximum when the velocity is a maximum, and the velocity will keep on increasing till there is a push from the spring, and the push from the spring is more than the friction, so that the velocity is increasing from the initial position. Find x. Okay, find x. So V max will occur till the kx push is equal to the total friction. At that spot the maximum will the velocity will be maximum. After that your friction will still remain 2 plus 2, which is 4, because it is sliding, and your velocity will start decreasing, because your x will decrease and the kx will decrease. So find x naught. So I think no big deal. They didn't ask us to find the velocity, we won't write the kinetic energy equation then. So K into x naught is equal to 4 Newton will give us the answer. K is 200 by 3 into x naught is equal to 4. So your x naught is equal to 6 by 100, 0.06. It had to be less than 0.1 and it is less than 0.1, so that's your answer for x naught. So further they are saying find the contact force between the blocks when they come to rest. So when they come to rest, so we have to find where they come to rest. So till they have not come to rest, you have kinetic friction acting. Block A is pushing the block B, and in its state B is pushing A back because of action and reaction. Both are having the same acceleration and velocity. So these kind of questions are very easily done by analyzing the energy. So when they have come to rest, what would have happened is, say the spring was initially compressed to an extent of y, and when the body has come to rest, the spring is now compressed to extent of, say they are calling it something, find, no, there is no letter given to it, so let us call it as x1. And if we write the energy equation, then the initial spring energy was half k y square. Finally the spring energy is half k x1 square, but they are not equal. There is no kinetic energy, so there has been energy which has been destroyed by friction. So friction was acting all along this length, and this length would be a y minus x1, and the friction acting was 4 newtons. So 4 into y minus x1, if I add to this, or if I would have taken this subtraction, the loss of spring energy, there is no loss of potential, there is no loss of kinetic, because that is starting and end is 0. Loss of spring energy is equal to the work done by friction, so that would have given the same equation. So solving this equation, we'll quickly write down the values. Half k 200 by 3 into x1 square, so this is going to give us a quadratic in x. 4 into 1 by 10 minus 4x1. So we have got a 100 by 3 x1 square minus 4x1 plus 4 by 10, and we have here, what we have is, this is gone, 1 by 3 is there, so plus 4 by 10 minus 1 by 3, so that's a 2 by 30, so I'll write it as 2 by 30. Is equal to 0. We may multiply 30 all over, and we have a 1000 x1 square minus 120 x1 plus 2 equal to 0. So x1 will be equal to a minus b, which is 120, plus minus under root of b square, which is 14400, minus 4ac, so it is 8000 divided by 2000. So 144 minus 80, that's a 64, so that's under root of 64 is 8 and then 00, so 80, 120 plus or minus, so minus is valid over here. The first instance where it the equation holds right is what we are actually contemplating and thinking, that is the thing which is happening after it has stopped. The second instance, what you get from a plus, would not be right, because if it is getting pushed, then the friction direction is going to be if it has stopped coming one way, then the friction is no longer there, so you cannot apply friction over there, so this plus is not valid, only minus is valid. So you have a 120 minus 80, 120 minus 80, which is straight away I'll write it as 40 divided by 2000, or it is 2 divided by 100. So it's a 0.02 meter, at which find the contact force between the blocks when they come to rest. There is a position when they have come to rest. Now when a block is moving, till the block is having a velocity, you have the full-fledged friction F acting, which is equal to mu n. Now when the body comes to rest, all of a sudden this friction becomes F becomes 0, because there is no motion. Velocity dies down slowly, but the friction all of a sudden will become 0 when there is no motion. So the body has come to rest at a certain position. There is no motion right now, and we'll see how much is the friction. So there is a push from the spring. This is the spring. How much is the push? Kx1 is the push. Kx1 is the push. How much is that push? So that F is equal to Kx1 is equal to 200 by 3 into x1 is a 2 by 100. So that's a 4 by 3 Newton push. Which is obviously below the 4 Newton which the bodies were together able to give as a friction. So it is 4 by 3 Newton is the push on this, and the body A alone is going to be able to counter this push. So the friction over here F will be 4 by 3 Newton, and the friction below the other body F will be equal to 0. As I was saying, when the body stops, then there is no relative motion. Then you have to see how much is the friction. Friction can all of a sudden become 0 also. So now this body is having no acceleration, body B is having no acceleration. It has to have no net force. Vertically it is not having, horizontally also it should have no net force. Body A is not having any net force. The push of 4 by 3 was there and a friction of 4 by 3 countering it. For B also there has to be no force. So this push from A, action reaction what they are calling, this R has to be 0. So there is no contact force. They have asked for contact force between the two blocks. So there is no contact force between the two blocks. Between block B and the ground there is a contact force of the normal action reaction. The friction is not there. The contact force between A and the ground, A and the ground, there is a normal reaction and there is this friction F is equal to 4 by 3. So that's the contact force of A with the ground. Normal reaction is equal to mg, which is 10 Newton. So the net contact force will be 10 square plus 4 by 3 whole square under root for A with the ground, B with the ground 0, B with the other block also 0. Next part of the question, take K is equal to 100. So they have now increased K value from 67 excuse me to 100. What distance x1 will the block travel together after being released before B separates out from A? So when is B going to separate out from A? So this is A, this is B. A was receiving a push and they have got frictions. So if there is no push on A is not going to push B. So if A and B are like, if the spring has passed the unstretched position, suppose the spring has passed the unstretched position, A is attached to the spring, so the spring is going to pull it back, B is going to separate out, because the B cannot be pulled back. So the velocity of A will get reduced not only by friction but also by the pullback from the spring, but the velocity of B will reduce only due to friction. There is no pullback, and hence B is going to separate out from A after the spring has come to the unstretched position. Before that, the spring is always pushing. So if the spring is pushing, if I study A alone, I assume there is no action reaction over here, then A has got a greater acceleration than B because it has got kx force forward acceleration I am talking about. So kx force forward, acceleration considered forward as A I am talking about, so kx forward minus F. However, B will have only this F backwards, and hence A's acceleration in the forward direction, A can have a negative acceleration by the way, A acceleration in the forward direction will always be greater than B. So it is not possible that while there is a push there is no action reaction. There is action reaction while the push is happening and while the bodies are moving. If the body has stopped, then obviously there is no action reaction, as we have shown over here. So we have to see whether the body stops with this new value of k, with a k equal to 100, whether the body stops before the unstretched position or not. If it stops before the unstretched position, then the body is never separating out. The action reaction may become 0 when they stop, but if it doesn't stop before the unstretched position, then the body will separate out. So easy way to check is would be the spring energy when the bodies have come back to the unstretched position. The spring energy would be would have gone from half k 0.1 square to 0, right? This would have been the change in the spring energy. The work done till this position of coming back to the unstretched position from this totally compressed position coming to this unstretched position, how much will be the work done by the friction? So work done by friction is going to be 4, assuming it is going the whole way, and then we are just going to compare whether the spring energy was more or not. 4 into the y, which is equal to 0.1. So let's just calculate this. 2 into 3 into 1 by 100. So that's a 1 by 3 joules, and this is 4 by 10, which is 1 by 2.5 joules. That means there must have been a position where the body has already stopped before coming to the unstretched position. Which was the previous situation? Oh, one second. In this situation, they have given the k value, they have changed. I'm sorry, I did not change the k value. The k value now is Yeah, I wondered why they had given a repeat kind of question. So K value now is half. K is 100. 100 into 1 by 100. Yeah, so that is a half joule. And this one is, so that means it is the work done is less than the change of spring energy. That means while the body has come back to the unstretched position, I'll repeat, while the bodies have come back to the unstretched position, spring energy still was higher and the friction could not kill the whole spring energy. The spring energy whole is not killed. That means here the body will have some velocity. Now if the bodies have some velocity, at this position A is going to separate out from B, because A will have a, going further, A will have a kx backward force apart from friction also, while B will have only the friction force as explained. So this is going to separate out when they reach the unstretched position. So unstretched position is your answer.